Now today's going to be kind of interesting compared to a lot of HTML5 talks that I've given, a lot of HTML5 talks that I've seen, in the sense that it is a completely set of impractical technologies that you can't possibly think about using in your applications today. And I know that there's an elephant in the room, and the elephant is HTML5 adoption. A lot of us are working in enterprises, a lot of us are working for clients and customers that are expecting that we deal with cross-browser compatibility concerns. They're expecting that when we adopt certain technologies that we think about how those things are going to work from one browser to the next, that we make sure that we deal with the browser inconsistencies that haven't managed to go away. That's all fun and very practical. I've given talks like that, I've written articles like that. That's not at all what I'm talking about tonight. So, just warning you now, this is all going to be very extraordinarily impractical stuff you can't use in any of your projects today. And I apologize in advance. However, I have a reason for going that way. Now, if you do still care about practical, if you really, like if you're still new to HTML5, you're still trying to wrap your head around how to use audio and video and how to use geolocation and things like that, I can recommend a lot of different resources. HTML5rocks.com, Adobe Developer Center, I've written a lot of MSDN articles that Sanjay mentioned that you can check out. And I've also, at TechEd in 2011, I gave a talk called App Development with HTML5. It's basically an intro to HTML5. I've given that talk dozens of times. That's the last recorded version. You'd think that it's out of date, but there is actually still a lot of relevant content in there. So if you care about practical, you can check that out. And that's the last practical thing that I'm going to say. Because the rest of today, and actually let me back up for a minute. Because the rest of tonight is about the future. And the reason why I'm going impractical, the reason why I think this is relevant and not just about having fun, is because as web developers, I think it's very important that we look at the past, the present, and the future. And the past is something we're all well aware of because we've lived through every painful moment of being web developers and doing things with web technologies. It hasn't been easy, no matter how long. If you've been doing it for 3 years, or if you've been doing it for 15 or 20 years, you know that this isn't easy. There's painful things to do. I was joking with Sanjay at lunch today about what it was like to try to figure out the selected radio button in a group on a web page before jQuery came along. And it was an impossible task. Not impossible, but it took more code than anything possibly should. Right, the web has not gotten any easier in some respects. But we have to we reflect on the past and we look at what we have today. We look at things like jQuery and we think, okay, now life's gotten a lot easier. This is great. We have new technologies. We have great specs in HTML5, and that's our present. But I think it's also very important that we spend time thinking about the future, looking at what's out there, because a lot of these things are not 2 and 5 years out. Some of these things are 6 months out. There are technologies that have just been specified by the W3C that will make it mainstream in all the browsers in the next year, including Internet Explorer. Even Microsoft has actually gotten the memo in terms of innovating faster with their browser. And between all of us, and I say this as someone who worked for Microsoft for 2 years, now that Steven Sinofsky is out, it's only going to get better. Just being completely honest. This is being recorded. All right, I'm sorry, Steve. He doesn't know who I am. In any case, all the browsers are getting they're getting this. We're not in the days anymore where the IE6 team gets completely blown up and tasked to work on something else, like another chat application. They're all working very actively. IE10 is just the beginning. Chrome 75 or whatever version we're on now is just the beginning, right? All of these things are coming faster than we think, and I think we need to be aware of them. Now, on the other side of that, I want to mention that these things are a little dangerous to play with at times, and I'm playing a little dangerous game by actually demoing some of these things for you tonight, because chances are more than one of them is going to go wrong, and you're just going to have to believe me when I tell you that they work and they're really fun and all that fancy stuff. If everything goes great, that's fantastic. But these are APIs that are cutting edge. These are things that are in flux. These are specifications that, as I'm sitting here showing you them, there are a bunch of people in academia, in IRC channels, talking about whether or not they need to change the names of some of these APIs in the specs. I mean, that's how active the work is on some of these things. We're going to talk about them anyway, but you need to be aware of this. What you'll see tonight when I talk about these things is that a lot of the stuff I'm going to show off is not supported in mainstream browsers. You can't play with it in Google Chrome, consumer version. You can't play with it in Firefox. You need a developer channel browser. Thankfully, both Chrome and Firefox have gotten really good at providing developer releases of their browsers. So one that I'm going to look at tonight is Firefox Nightly, which you can get at nightly.mozilla.org, and the other is Chrome Canary. And Chrome Canary is at bit.ly/Chrome Canary. Now, what's awesome about Chrome Canary, and this is not the case for Firefox, is that you can run Chrome Stable and Chrome Canary side by side at the same time on your machine. With Firefox Nightly, you can have them both installed, but you can only run one at any given time. So a lot of people, like Paul Irish will tell you, and Sanjay's going to get Paul to come down here. I know, he's going to come. Paul will tell you that he runs Chrome Canary as his day-to-day browser, and that's awesome for him, but I don't do that, because it crashes a lot, and it'll crash your machine. But you can play with cool demos in it as well. So you'll check these two browsers out, and along those lines too, some of this stuff is so experimental that not only is it only in these Edge dev channel browsers, is that you actually have to go into a special settings place in Chrome to turn these things on. So when you read articles about some of these cutting edge technologies on a site like the Adobe Developer Connection, ADC, or you read about some of these things on HTML5 Rocks, you'll see the author mention opening Chrome flags in the browser, or about flags, and activating a certain feature. So that's something you want to pay attention to as well, and you'll see exactly how that works here in a moment. So most of the meat of the talk today is going to be a lot of demos, which I hope you're cool with. Not a lot of me just rambling. There's going to be you actually seeing these things working, because some of them need to be seen to really be appreciated. And I'm going to start by talking about Eggman Script, or the standard that JavaScript implementations in the browsers is based on. So hopefully we all know that Eggman Script is the actual official name for JavaScript as it is specified by ECMA International, which used to stand for the European Computer Manufacturers Association, but now just stands for nothing. It's just ECMA International. And that is the organization that actually defines what JavaScript looks like in our browsers. They own the Eggman Script standard. So if you hear somebody talk about ES3 or ES5, they're referring to Eggman Script, version 3 or version 5. So for years and years and years and years and years, and far too long, the version of JavaScript that was supported in our browsers, or Eggman Script, was ES3. And ES3 had a lot of the JavaScript that most of us probably grew up using, that we've been using for a while. And then about 4 or 5 years ago, a lot of browsers started implementing Eggman Script 5. But there was no Eggman Script 4. The fact of the matter is there actually was an Eggman Script 4, and the committee in ECMA International that was working on standardizing this was actually making a lot of headway in really drastically changing the way JavaScript was working in the browsers. And this was even in the late 90s. And in the early 2000s, that completely fell apart. This was again around the time where IE6 was around for way too long, and so Microsoft was not on board with the S4. Mozilla was actually not entirely on board with the S4, even though Brendan Eich, the creator of JavaScript, works for Mozilla. He's the CTO. And so there was a lot of contention over ES4. So after a while, it was scrapped. It was just considered, it was deemed to be way too cutting edge, it was scrapped. And so what happened at that point is all of that stuff got moved to the table and it got branded Harmony. These were Harmony specifications, and then the committee started working on ES5. And ES5 is what we have in the browsers today. Chrome, Firefox, Safari, Opera, and IE9 and above all support ES5 5.1. And that gives us things like strict mode, it gives us some better actually defined properties on objects with a little bit more granularity. That stuff's really nice, but it's very conservative. There wasn't a lot of innovation there. By and large, other than those things, JavaScript, the language, has not changed much over the last 17 years. And ES6 actually changes all that. So everything that was moved from ES4 into Harmony, a lot of that stuff is back on the table now in the form of ES6 specifications. And many of those things is widely supported by all the browsers and every committee member. And that's things like default and rest parameters, and for of, and map and set, and proxy, and modules. And so I highly recommend, hopefully you've had a chance to write this link down. If not, just write down the title of the blog post, which is Harmony of Dreams Come True. Brendan Eich wrote a blog post last month after he spoke at the Strange Loop conference, where he actually went through all of the ES6 features that are landing in the browsers very soon. The fact of the matter is that JavaScript, the language, is actually going to be fundamentally changing over the next 6 to 12 months and beyond. And this is a good thing because we are drastically missing some features. A couple of those are things that we've taken for granted in other languages for a long time. Any C# developers, historical C# developers, Java, Ruby. Default and rest parameters are things that those languages actually have in one form or another. Ruby has rest parameters. All three of those languages have default parameters. And that's very simple, right? All I'm saying in this case is I'm going to give, in this function, I'm going to define it with two parameters. If you don't give me a value, the default is 0 for A and A times A for B. So in this case, when I pass in function 2, it returns me an array of 2, and 2 times 2, which is 4. So now I don't have to worry about if-then checking for getting valid parameter values, because again, JavaScript's dynamic. I can call a function without actually specifying any parameters. The other thing I can do with REST parameters is I can define this parameter that's used to basically take everything else that a caller actually will provide to me. So I can define A, B, and then ... others. And what that's going to provide me is an array of all of the other values that get provided. And this is very different than the arguments object in two ways. One, the arguments object is not an array. It's an array-like object that's a real pain in the butt to work with. And the other thing is that the arguments object has everything, including A, B, everything that gets passed in. So what you get with this others object, with this REST parameter, is an array that only has everything else. And so what I'm doing in this case is I'm taking that others array, concatenating my initial two parameters, and sending it back. So what I get here when I pass in 1, 2, 3, 4 is an array of 3, 4, 1, and 2. And those are really useful. They're minor. They're minor features, but other languages have had these for years. And it actually saves developers a lot of pain. Brendan Eich said that his hope is that these two features actually just kill off the arguments object forever. Another awesome feature is modules. So if you've been using Node.js, anybody fiddling with Node.js? So if you've used Node.js, you've used Required.js, anyone use Required.js in the browser? Both of those provide a concept of getting module support in your applications. And we're actually going to get first-class module support in Eggman Script 6. And what this means is for the first time ever, not only can we encapsulate functionality by defining first-class modules and explicit exports of functionality outside of those modules, but we'll have the capability to actually perform imports of other functionality without littering our applications with thousands of script tags. So I can now include jQuery inside of a script by just saying import $ from code.jquery.com. And I'll have that capability in the future as well. Another great feature is classes. And this is one that's actually a little bit controversial because a lot of folks that have been using JavaScript for a long, long time don't think there's anything wrong with JavaScript's prototypal inheritance. And I don't either. I don't think there's anything wrong with it. But I do think that the nature of inheritance in JavaScript really trips up a lot of developers coming from other C-like languages because you don't have class-based inheritance like you do in C# or in Java. So this actually makes that on-ramp a little bit easier in the sense that now you actually get first-class class support. And it's optional. So somebody that doesn't like it doesn't have to use it, but that provides that extra level of support, extra level of features. So my plan was to actually show off a few of those Eggman Script 6 features. However, Firefox, like I told you, Firefox Nightly has been terrible to me all day today. And so I will try to turn Firebug on and see what happens. I don't even think I'm getting the console here. What is happening? Pardon me for a second. Oh, there it is. So, all right, I'll tell you this much. If you actually want to try some of these Eggman Script 6 features, a lot of them are implemented in Firefox Nightly. Modules and classes are not yet, but REST parameters and optional parameters are supported. And so what you can do is you can open up Firebug and Firefox Nightly and play with those things in the console. Firefox actually tends to be one of the first to implement new JavaScript language features, partly because the creator of JavaScript is their CTO. So they're always going to be one of the first to implement these things, try these out. They've had features in that browser for years that have never been standardized, like __proto__, right? What is now trying to be proposed as this first-class prototype object on every other object is something that Mozilla's Firefox has had for ages. I would love to show you this stuff, but apparently Firefox Nightly will not allow me to write multi-line JavaScript code right now. So there's nothing I can do. But that's okay, you trust me, right? It'll work. Try it out, mess with it. Firefox Nightly is the way to go. So the next thing I want to talk about is I want to spend some time talking about bleeding edge features in CSS. And I love CSS. I especially love a lot of the CSS3 modules. I am not a designer by background, I'm a developer by background. I wish that I was good enough to be a designer because this stuff is awesome. Like, I love the stuff that designers can do. And I love that CSS has actually grown by leaps and bounds in the capabilities that it provides developers and designers. And some of this stuff is getting even nuts and how awesome and what you can do. And I'll show you a few of those things tonight. One of these is CSS Regions. And CSS Regions is in the family of layout modules. So hopefully we're familiar with CSS Flexbox, which gives me the ability to define rules for laying out boxes in a as it sounds, a flexible way so they will flow correctly across the DOM. Multi-column layout is good for text. Microsoft has the CSS grid specification, which is a key point of their Windows 8 platform. And then there's another called CSS Regions. And CSS Regions is similar to multi-column in the sense that it gives me control of how I handle text layout in a responsive way. So this is actually very tied to responsive web design in the sense that I'm defining text and then defining rules in CSS for how that text automatically flows into containers. And so this will make sense when I show it to you, but I'll explain it very briefly. I have some source text that's in a paragraph tag. That paragraph tag is a really, really long, meandering paragraph. Let's say it's an article on a newspaper site, New York Times, right? And I have a container that has a couple of divs with the class of region. And what I ultimately want to do is I want to take that text from that paragraph tag, remove it from the DOM, and distribute it into those 3 different div elements below. And what CSS Regions allow me to do is say flow into, and I'm using vendor prefixes for this one. This is only supported in Chrome Canary right now. Flow into main, so I'm creating just a fake name of something to flow into. And I'm saying remove this from the ID source and flow it into main, this imaginary place in the DOM that you're going to wait for me to tell you where to put it. And then for all of my region elements, I'm saying flow from main. Take it from here, put it in here. And what it ends up doing is it takes the text and it puts it in the first box. And if there's more text than there is room, it doesn't change the dimensions of the box. It respects those dimensions. If there's more text than room, go into the second one. If there's more text than room, go into the third one. And I'll show you what that looks like. Goodbye, Firefox. Okay. I am done with Firefox. Everything else is pretty much going to be in Chrome Canary for the rest of the evening. Now, in order to get this to work, and it'll be interesting to see how this works on this 1280 by 800, I actually have to enable regions under Chrome flags. So this is what Chrome flags looks like. That Google gives you every chance to know that this actually might cause you problems. In order to find this, let me see. I feel like I'm not actually getting. There we go. Yes. Oh, I know where it is. I'm sorry. So here's another thing. You may read an article that says, enable this feature in Chrome flags that was written 6 months ago, and then Google goes and changes where the flag is. And they've done that actually. There used to be a flag that was enable CSS regions, and now it's actually enable experimental WebKit features. which includes Chrome flags, it includes regions, it includes Shadow DOM, it includes CSS variables. We are going to talk about Shadow DOM tonight, hopefully. We will not talk about CSS variables. But once I've enabled any of those features in Chrome flags, I have to restart the browser, and now I can get this fancy feature that works. So here's my text. I'm going to open up the DevTools, which are always your friend. And notice, can everybody see DevTools okay? I have some source text here, right? It's just 3 paragraph tags. And then I have a couple of other where'd that go? Content, okay. And then I have some other divs, a 1-column div, a 3-column div, and those all have this region. Now you'll notice here on my source div that the container for my source divs actually has this WebKit flow into property. And the container, each one of these regions has this class WebKit flow from. So what's ultimately you're going to see happening is that text is being taken out of the DOM and flowing back in. So I'll prove that to you by unchecking this, right? You can change properties in the DevTools. And now that text is gone. Even though it's in a paragraph tag, it was on the page, as soon as I had the CSS property to flow it out of the paragraph, it's invisible. I have to say where it goes next. And so I say flow from main. And here's the advantage of that. Watch as I resize the screen here. You'll notice that the text here is actually moving out of the top section, and more of it's moving into the 3 boxes below. And so as I resize the screen, I haven't had to do anything except define the size of those boxes, put those divs on the page, and specify a couple of CSS rules. And now I have I have text that is completely responsive, regardless of the size of the user's device. I don't have to have any media queries to support this. This is all supported out of the box. That's pretty exciting, I think. I'm biased. I love HTML.
Did those child containers have to be placed somewhere specifically? So, I mean, what if your parent or your main thing is up here and your other one is way further down below? How it's going to flow?
It's going to flow in order. unless you actually, there's some talk about actually adding some experimental properties that allow you to change sort of the order of how things flow and which containers they flow into. But in theory, what it was conceived for is for adding those kinds of flexible layouts in like a magazine or newspaper. And so things will flow just like the box model does now. It'll flow top, left to right. Or if you're or if you have RTL support in your app, top, right to left, right? But it'll flow in DOM element order based on the box model. So if you have a DOM element that theoretically is in order, but you've done something crazy, like performed a CSS transform on it to move it to the bottom left of the page, it actually will flow because as far as the rendering engine is concerned, that element is up here. You've just done a transform to move it. So you have to. Does that answer your question?
Yes, sir.
Okay. All right. Cool. The other two CSS things I'm going to talk about are pretty neat, and it's if you want to like Instagram all the things, you'll love CSS Filter Effects, because ultimately what you're doing is you get this filter property's actually been around for a while. I had this for ages. They use it for SVG filtering. And so filters were originally conceived as a way to add post-processing effects to SVG elements. And what we have now is that's actually been generalized, so you can actually add filter functions to any DOM element on your page. And these filter functions, there's about 5 or 6 of them, things like sepia, grayscale, hue rotate, blur, and you can add any one of these functions in that filter. Of course, you have to use your vendor prefixes and add those filters to an image, to a piece of text. It doesn't necessarily have to be an image. This is actually something that is supported in Chrome Stable and in Firefox. It's not yet supported in IE 10, actually, so it won't be. It might be coming in IE 11. Hopefully, let's cross our fingers. And I'll show you very briefly. So I have this photo gallery application. I tend to use this a lot. So I know you saw this already today. I use it for different demos. It works. Photo galleries, everybody's got those, right? And I have hover effects, so anytime I hover over one of these things, you can see some extra detail about the image. I have my rounded corners, which means it is an HTML5 application. I got box shadows and all that kind of stuff. And I have some buttons down here because I want to perform some of these effects. And so what I'm going to do is I'm going to open up my desktop CSS. I'm going to navigate to the right place on the page. And I'm going to add each of these as classes. So these are all going to look the same. It's just a different function. The grayscale class, when applied, will perform a filter on all of the images on my page and set it to 100%. Same with sepia. Hue rotate is by degrees. Blur is by pixels. Invert by degrees as well. So I can apply all of those effects. And then in order to actually do that, I'm going to add a little bit of JavaScript to actually respond to the button clicks. And all that's doing is just finding out which button was clicked and then using that ID of the button to apply the filter. The IDs and the class names are the same, so I can keep my code kind of nice and terse. So when I refresh this and I click on any one of these buttons, I get that sepia effect, and that happens. That is a post-processing step on the image. Same thing with hue. Blur is one that I really like. It's kind of cool. Now what's interesting about this is if I actually open this image up in a new tab, this isn't doing anything to the actual base image, right? The browser doesn't have access to that base image. It is performing that as a post-processing step. So the rendering engine is repainting that bitmap and showing it to you again. And it's doing that applying CSS, which is really nice. Now, as nice as CSS filter effects are, there's only 5 or 6 things that you can do with those. And so Adobe, a couple of years ago, actually proposed an extension to this specification that they called Css Shaders, which actually give you the ability to create GLSL shaders, which is crazy to think about, and actually perform effects in just CSS, perform richer effects. And this is just doing it in grayscale, but I'll show you another one in just a second. So the way this is, they basically added this custom function. And this custom function gives you the ability to define your own fragment and vertex shaders that you apply. And those fragment and vertex shaders are written using the OpenGL shader language, which is C. So if you feel like writing C and you like doing web development, then you have an outlet for your creativity. However, you don't have to do this. There are a lot of shaders that are going to be available open source. Adobe has already released a bunch of those through their Filter Lab project. Ultimately, all this is just giving you another avenue for taking input and performing pixel-based manipulation on a bitmap. Coincidentally, and we'll talk about this in a second, is if you're familiar with WebGL, GLSL is the same language used to write shaders for WebGL. So this is actually now making its way into CSS as well, which is pretty fascinating. Let me show you that, because that was one that I think is pretty crazy. So I have, again, same images, a little bit larger because I'm going to perform a different effect. And what I'm going to do this time, go to a different one, is I'm going to actually add that shader to the hover for each one of those images. So I'm only going to perform that custom filter when I hover over the image. And so let's take a look at the syntax, of course, for this is likely. I have to just trust me on this. I'm basically calling a couple of shaders that I've defined to perform what I'm calling a crumple effect. I'm passing in that crumple vertex shader, I'm mixing it in with a fragment shader and setting a bunch of other properties. That's all fine and good. Let me show you those shaders very briefly. Those are all defined here. Again, these are FSC. And it's not stuff you have to write on your own. It's readable enough. You can kind of see what's happening. If you're familiar with GLSL, this is going to make perfect sense to you. That's fantastic. So let me save this, and now I will refresh and hover over one of these. Check that out. Now what's awesome about this is you'll notice that it's not just the image that actually got this effect. The box shadow, the wrapper, container around it, and the text actually were all manipulated in the same way. So these shaders, these custom filters actually can be applied to any DOM element whatsoever. They can be applied to text in addition to images. And the sky's the limit in terms of what you can do with these things.
Is that text selectable?
That is a great question. Well, I'm hovering over it. If I didn't have the shader on, I wouldn't be able to because it's part of the main image itself, right? Once I've hovered over this image and there's a, it doesn't appear so. Good question. So those are custom filters, and those are things that, I mean, Adobe actually proposed these. This is Adobe is actually doing some amazing stuff in the oh my God, Flash is dead, we've got to do something department. And it's amazing. And they have put all of their creative talent and all of their experience in years with creative technologies into really pushing the boundaries with CSS. And this stuff is in Chrome Canary today. It'll be in Firefox in no time. It's going to be in all the browsers soon enough. So let's talk about some JavaScript APIs. Oddly enough, the JavaScript APIs that I'm going to talk about are not so bleeding edge that you can't possibly find them in any of the mainstream browsers. I'm going to talk about Get User Media and Webrtc, which actually is supported in Chrome Stable and should be landing in Firefox very soon. Get User Media is really exciting because it actually gives you as a developer control over accessing a user's webcam and microphone and then streaming that content into HTML5 video and audio text. So you can actually do real-time streaming in the browser with audio and video. You don't need plugins. So this is sort of the last, not the last, because gaming is still a big one. This is one of the last frontiers in terms of where Flash has definitely still had an advantage over the last couple of years. And so what I'm essentially doing here is I'm calling the Get User Media object, which is a global object on the Navigator JavaScript object, saying I want video. My callback is streaming video. I'm taking my stream and I'm setting that through the object, getting an object URL and setting that to the source of my video tag. Now, WebRTC is an extension of that because video chatting with just yourself is lonely. WebRTC actually gives you the ability to pair Get User Media with WebSockets and actually do asynchronous real-time communication in the browser, peer-to-peer, with no plugins, no Skype, no nothing. And I'm actually going to demo that with one of my buddies who actually agreed to hang out and let you guys see that. Hopefully, if he didn't bail on me. I'll show you Get User Media very quickly so you can see how that ends up being implemented. So open this up. I need that first. All I need to do in order to start working with this is add a video tag to the page. That's it. I'm going to add a video tag with some controls. Save that. I'm going to go over to my JavaScript, which is where the real work here happens, of course. And this is very similar to what you saw on the slide. Let's see if I can. This text down. Ah, there we go. Maybe not too small. All this other stuff up here is just dealing with the vendor prefixes. We have those in JavaScript too, unfortunately. And I'm just having my Get User Media callback. I'm doing exactly what you saw on the slide. I'm setting it to the object URL, and that's as good as that. Much like a lot of these other specifications, this is opt-in, right? You can't trick somebody into giving you access to their webcam or video. The specifications are very clear that you have to give permission. So if I give permission, I say allow, it'll turn on my webcam. I'll get a notification from Google that it's on and I'm now streaming video. This is just a video tag. I can pause it and walk away because I put controls on this. When I unpause it, it'll go back to live. I can go full screen. You don't want to see that. No plugins. That's in the browser. And like I said, that's not terribly interesting by itself. So let me go to, there's a great demo site that you can go for this. For this. It is, what is it? apprtc.appspot, excuse me. There we go. apprtc.appspot.com. And this is, again, this is Chrome. I can do this in Chrome Stable. I don't need Chrome Canary to do this. This will do the same thing, ask permission for my webcam or microphone. Once I've got that URL, I can share that URL with anybody. I will share that URL with Mr. Thomas Burke Holland. See if he joins me here in a minute. I'll walk away. Probably a good time to ask any questions. That's it. If anybody has any questions about this or anything else I've talked about so far. Nothing.
Can you apply one of those shader filters to that?
Yes,
Live video?
absolutely.
Yeah.
In fact, one of the coolest things that I've seen, there's some really awesome stuff that I'm seeing done with Get User Media and WebGL combined. As WebGL, and you could do shaders, but a lot of people do with WebGL is they'll create these like in-browser camera applications. So, hey, Kurt, what's up, man? I'm good. Oh, wow, how you doing? You sound like the digital representation of what the box you're wearing on your head. Cut a mouthful, yes. All right, wave, everybody, wave to Burke. Not while you're there, you can't. Burke, wave to everybody. All right. Thanks, man. That's it. I'm cutting you off. Appreciate it, bro. Thanks, man. Again, the audio quality was great when we tested it this afternoon. I promise you. Like, I do Skype calls every single day, and the number of times that Skype doesn't drop, I mean, I can count on one finger. But this was fantastic. I mean, we actually did a chat for 15, 20 minutes, and I've done it before. Again, all in browser. It's all using WebSockets and Get User Media to do this kind of stuff. Now, in terms of the great question about what you can do with Get User Media and applying WebGL or filter effects, there's this great website out there called Webcam Toy that you can apply. Yes, lots of clicks. This uses your webcam and then allows you to apply these filter effects in real time. Right? And there's some really crazy ones. Let me get to one of the really good ones. I'm probably wasting lots of time. All right, so and this is actually, so what this is ultimately doing is this is streaming all of this. What you're seeing is actually not being output on a video tag. What you're seeing is actually the Get User Media call streaming to an HTML5 canvas and applying WebGL filter effects based on that. So these are all GLSL shaders, the same stuff you can use with CSS custom filters and the same stuff you can use with WebGL. Now, I will mention this because it is exciting. We had this idea, Kendo UI had this idea first. I'm just going to share this. And so what we actually just got finished doing for Google is we implemented a very similar application for Chrome OS. So what you'll see in the next couple of months is when you buy a Chrome box or a Chrome box or a Chromebook, is that what will come installed by default is this webcam application that's very similar to this and has the same effects, and it's going to be pre-installed on every Chromebox and Chromebook. And that's something that we built actually using Kendo UI and taking a similar approach. It's all WebGL, applying these filters. And the whole reason we did this for Chrome, for Google, is because they're actually going to announce, like next week, the ability to build out-of-browser, native-looking applications using Chrome that actually don't run inside of the Chrome. So they look and feel like native apps, very similar to what Microsoft is doing with Windows 8, but they're using Chrome, the browser, as their host for letting you step out of that.
Is that like Adobe Air?
Very similar to Air. And Air, the one thing people always forget about Air is that Air actually gave you the ability to build native apps with, build out-of-browser apps with HTML and JavaScript. They're one of the first to do that. They're very similar in that respect. The difference is that Google is because of all of the native APIs they're exposing through the browser, like things access to the desktop for geolocation, battery status, all that stuff, is that you can actually build what is almost very equivalent to a native app, just using their technologies, which is something you could, in all fairness, do to a certain extent in there as well.
Will they be doing it in the Firefox OS?
Well, so Mozilla's doing something different I'm going to talk about in a little bit that's equally as exciting. But I don't want to
Okay.
ruin it. That's really good. If you're a Mozilla fan, you're going to love what Mozilla's doing. So I've talked about WebGL, hinted around it a little bit. This is not raw WebGL by itself because that would be a lot of code, more than I can fit on one slide. But this is a great library called 3JS. I highly recommend you check it out, 3js.org. And 3JS is a JavaScript library that actually allows you to work with WebGL and Canvas and has automatic feature detection, polyfill support. So you can build Canvas, you can actually build WebGL, animations, and effects, and if those need to fall back to Canvas, automatically it'll handle doing some of that for you. But it gives you actually it gives you better APIs at actually doing all that crazy WebGL stuff, because WebGL by default is really, it's similar to custom filters in the sense that you're writing control code in JavaScript, so similar to declaring those filters in CSS, but the real work, the real effect work happens in GLSL. It happens in those very complex shader files, and they are complex. So let's take a quick look at WebGL, and I'll use 3JS to show you some of this. I have an animate button on the page, and so I'm going to start by creating my init function. My init function is going to, a little bit, basically create a camera. Any 3D graphics and animation, you need to have a concept of a camera that's actually viewing a scene from a certain angle. I set the position of the camera. I create a scene that includes a cube and a mesh around that cube so it gives it shape and dimension. I add that to the scene. I create my renderer, and then I append that renderer to the DOM. And that's how I've initialized my WebGL animation, or WebGL illustration. By default, all that's going to do is just draw that out once. But in order to add some animation, I'm going to add an animate button. And when I click that, what that does is that triggers this function. Now this is something that I don't have a specific slide for, but is important in the context of HTML5 animations. It's very important for HTML5 games. And this is Requestanimationframe. So this is a new API that actually gives you some browser-managed callbacks. So instead of having to use set timeout or set interval and specifying, call this timeout every 16.666667 seconds, which is what you need for 60 frames per second, you're telling the browser, give me an animation frame as soon as possible. And the browser manages that for you. If the browser can give you 60 frames per second, it's going to call it back. And you better hope your code is tuned enough to run in less than 16 milliseconds when it calls it again. If it has to run slower, it manages that. And this is actually really nice because if you've ever seen really choppy animation, one of the worst things you can do with animation is strive for 60 seconds or 60 frames per second and be bouncing back and forth between 20 and 40. That looks horrible to a user. You're better to give them 30 frames per second consistently than you are to try to give them something higher every once in a while. So Requestanimationframe actually gives you that. It actually manages a lot of that for you. The other advantage of doing this is that when your tab is not active, like what Chrome will do, is when that tab is not active, when the user is obviously looking at another tab in the browser window, it actually will slow down that animation considerably. So now you're not actually using the user's battery. You're not killing their processor. Because as you've heard, when you do anything 3D in any of the browsers, your fan turns on like immediately. So this is a great way to heat your house in the wintertime, is to mess with things like in animation. And so once I've done that, I've done all those things, I've got 3JS ready to go. I'm going to click Animate, and I've got this nice little cube here. And this is just an HTML canvas element, but it is using the experimental WebGL rendering. So if you've used Canvas before, you know that when you get the Canvas context, you basically call canvas.getContext and then pass in a string that represents the rendering API. The only one that's supported across all browsers today is 2D. WebGL is not supported across all browsers. And between us, it would be very interesting to see Microsoft ever commit to supporting this. It's going to take 80% browser penetration for Chrome in order for this to happen for Microsoft. Because, and the reason, and this is not an official because again, I don't work for them anymore. My guess is the reason why that is the case for Microsoft is because WebGL directly competes with DirectX. So they have their own proprietary graphics technologies on their platform, and so they have a vested interest in not doing this. So when you write rich 3D applications in Windows 8 today, you use DirectX, you don't use something like WebGL. However, this is supported in Firefox, it is supported in Chrome, and Chrome and Firefox combined do have quite a bit of market penetration now. Microsoft is no longer the leading browser, so this is something to definitely pay attention to. That is WebGL. The last one, I probably get overly excited about this last one here, because it may not seem too terribly exciting to you guys. This is a relatively new specification, the JavaScript Speech Api. And this API actually gives the developer access to the operating system's underlying speech recognition capabilities from the browser. And so Google submitted this specification to the W3C. You probably know that for a while now in Chrome you can hit this little Speak My Search button, and it'll access your microphone, and you can speak your search text and then do a search. That's part of the work that they put into actually proving this out. And so what you get with this speech, and this is not doing a web search behind the scenes, it's not network dependent, it's not calling some API. This is using to be honest with you, the speech to text capabilities on the operating systems now are amazing. They're great in Windows 8, they're great in Windows 7, they're phenomenal in Mountain Lion. I mean, the integration that they've done in the speech to text recognition, I feel bad for guys like Ray Kurzweil who built all these like Dragon naturally speaking tools and stuff, because they've basically just been put out of a job. I mean, that's how good this technology is, and it's built into the operating systems. You get that now in the browser. And so I basically can create a speech recognition object, specify how many alternatives I want you to give me, because every time you speak, obviously that comes with a level of confidence. How confident the browser is that what you've said is actually what the user said is what it thinks it actually meant. And then I can do something with that. So instead of belaboring that code sample, I'll actually show you how that works. This is something I am not 100%. I'm going to do the easy demo, which is basically just populating a search text box when I say click to speak, and that's it. So the way that I'm going to do that is I'm going to start, as you saw on the slide, by creating that speech recognition object. I'm going to add a function here that does a few things for me. I'm going to say what I'm going to do first is when the audio starts, when this is ready, because this is, again, experimental. Every time I've tested this, I have to refresh the browser a couple of times for it to work. Again, this is crazy new stuff. This will tell me, okay, ready, you can speak now, and I'll capture something. And then I have an onResult function. What that effectively does is anytime I've paused long enough for the recognition software to say, okay, I've got something for you, it will fire this callback. If I get more than one result, then I'm going to check and see the confidence level of the first result. It'll give me a collection of 5 results as speech recognition result objects, and every one of those will have 2 parameters or two properties I care about: confidence and transcript. Confidence value, it's in order from the most confident to the least confident, is a number from 0 to 1 that specifies how much the browser thinks this is the text you spoke, and then the transcript is the text that it thinks it heard. So this can actually be kind of fun too, because some of the stuff that comes back sometimes is kind of crazy. And then the last thing that I'm going to get, I mean, speech recognition is great. When you ask for 5 results and it thinks it knows one, it's just going to start making stuff up. It's crazy. And when I click the button, I'll actually start trying to recognize what you said. And I'm going to put a breakpoint here so we can actually see what's happening in the DevTools. Always enable. Always enable. So I have a handler here. Refresh again just for good measure. Everybody be quiet when I click to speak. Okay. It's going to ask for my permission. Hey there, how you doing? Awesome, that worked the first time. Amazing. So now I'm broken into this. I can check my event.result object. And notice I have this array of speech recognition objects here. And so let me expand this even further. The first one, it's 80% certain that what I said is, hey there, how you doing? That's accurate, right? But the others are great. Hopefully, I'm disappointed. So it thinks I may have said, hey there, how are you doing? But it has 0 confidence in that. That's not that much fun. Hey, are you doing? Okay, it doesn't have any confidence in that. Hey there, are you doing? Oh, come on, give me a funny one. I'm not going to keep doing this again. And are you doing? All right, well, whatever. Play with this because it's kind of neat. So what I actually did then in my source code is if the confidence level is greater than 0.5, I'm going to put that in. I'm going to go ahead and copy the transcript, the value that it thought it heard, into the search text box. Right? And so voice search, that's going to be one of the most simple examples that you heard, that you'll see. I think this is awesome, and I think this is awesome actually for accessibility reasons. This is why I love this so much. And I'm in the process of writing an article for the Adobe Developer Center on this topic, because what I would love to see is websites that actually use this speech recognition capability to allow a disabled user to navigate a form, to navigate a collection of data, to actually enter and interact with a web application using just their voice. That's much better than anything a screen reader could ever possibly hope to offer. And that's pretty neat. Oh no, and of course I just closed Canary. Thankfully it's fast. All right, so that's speech. That's this JavaScript Speech API. And the last piece that I want to talk about is bleeding edge stuff in the HTML and the DOM. And you're probably thinking, man, why did you save the boring stuff for last? Like CSS and JavaScript is fun, but like markup, man. I say this for last actually, because the stuff that's happening with markup and with the DOM is crazy to think about. I mean, this is stuff that I can't even show you most of it. It's that bleeding edge. It's not demoable in any browser. And one of the things, I actually needed a custom build of Chromium in order to be able to show you. So there's crazy stuff happening. One of these is responsive images. And I love, love, love the work that's going on here. Because this solves a big, big problem that we have. Everybody I know, and we talked about it earlier, is familiar with responsive web design. Responsive web design was a term that was coined by Ethan Marcotte in an article he wrote for a list of part back in 2010. And there were three key pieces to responsive web design. The first piece is media queries, which hopefully you guys are familiar with. Conditional rules apply based on metadata about the browser's viewport, pixel density, et cetera, et cetera. The second is a flexible grid. And we've seen a lot of that with grid specifications, with multi-column layout, with CSS regions. We're dealing with those things. The third piece is flexible images. And this is the thing we're having the most problem with. Because what flexible images really means is not that I send a 1 meg image down to a mobile device and make it really small. That's irresponsible. Right? Because we're killing users' data plane by doing it. To send 1, 3, 5 meg high-res, Retina makes it even worse, right? Sending these 20 meg Retina images down to mobile devices and thinking, well, if I make it really small and it fits the screen, it's okay. And then they're...
You're on edge.
What's that?
Especially if you're on edge.
Especially if you're on edge. Oh my gosh. That's, which does still, yes, it does still exist. It may seem fine if you're on LTE and you're cruising down the highway like, oh, look, I'm browsing at 18 megs down. But, I mean, this is something that we've had a lot of problems with. We haven't really had an answer for on the client side. There are server-based solutions. There are solutions for this that a lot of folks have been, really intelligent folks have looked at over the years. But what we've missed in a lot of ways is the ability to do this just on the client side. For the browser to give us the ability to specify conditional rules for inclusion of images. Now, there's two actually competing specifications for this, and there's a long history of the debate between these two. I'm a little biased, so full disclosure. I am a member of the Responsive Images community group, and so like I like what we're doing more than I like what Ian Hickson is doing. However, there is compromise that's been reached. I'll talk about both of those very quickly. One of these, the first proposal is the picture element. The picture element is a proposal for a brand new element, but it's actually inspired by the video tag. You may not know that what you can actually do with the video tag today is when you specify multiple sources, you can use a media attribute in the video tag and then specify media queries to determine which video tag you want to send down. It's not just actually supporting multiple formats, multiple encodings. It can actually be used to send a lower, higher fidelity video down based on the media qualities of the user's device. And so the idea here is to do the same thing, to allow me to specify, send a really big image down when the user's on a full display, but tune it down, send me something a lot smaller if I'm on a smaller screen. Now when this was first proposed, the way that W3C works is that working groups are not the same as community groups. Like community groups, anybody can join, which is why they let me in. But it's not really an official working group. Like we don't have any power or authority. We're just a bunch of developers that are sitting around navel-gazing, talking about the way that we wish that HTML could be better. You know, working groups are the ones that are actually debating these things. And so there's been a long road to actually get this kind of stuff accepted. What happened around the same time is a group in one of the people in the WHAT working group, or the Web Hypertext Application Technology working group, that Ian Hickson chairs, proposed a different solution for this. And they specified they wanted to use a new tag called source set, a new attribute called source set. And what source set would do is it allows you to do effectively the same thing with a different syntax. It's more terse, but the big complaint here from a lot of developers, myself included, is I don't know what the heck this means. It's very, very hard for developers to figure out and reason about what this means, especially if you've not been